So in kind of tying things together for everybody that was here in the room for the previous talk, kind of the same thing in terms of getting people in defense to kind of up their game. David Mortman talking about developing RESTful APIs and tailoring them towards defensive technology. And then for those that weren't in the room for the prior talk, I want to make the same request for the defense track that I did for the talk prior, which is I have a policy for all the talks in this track that anything that contains the word cyber. Thank you. So my opinion is that anytime you hear the word cyber, it's generally followed by bullshit. So I would like everyone in the audience to please scream bullshit. So cyber, bullshit. Cyber, bullshit. Defense information cyber plateau. Boom. So just please try to keep that going. If you can carry that with you to other talks and other tracks as well, I would appreciate it, including keynotes. So without further ado.
Especially keynotes.
Especially keynotes. Without further ado, David Mortman.
Man, now I'm really tempted to throw cyber in all over the place. Thank you. Yeah, there's the mandatory, please fill out the feedback slides. You'll see a lot of this over the next 2 days. Please do so. Yeah, I'm David Mortman. I'm the Chief Security Architect at Stratus, and I'm not going to talk anything else about what I do there, so you can ask me later. The general problem I'm trying to address today is that a huge percentage of the actual security incidents that happen today aren't because people are super elite hackers. You're going to hear a lot of cool talks later today and tomorrow. People can do some badass shit. You're not going to see most of those attacks in your everyday life as a defender. What you're going to see is, I forgot to get rid of a default password. I forgot to turn off HTTP. Really basic stuff. But nonetheless, it's a hard problem to solve. Some centralization, some automation can help with this, so that way you can focus on the hard problems, like doing identity management. That's a real pain in the ass. That's another talk, however. And the best way to sort of help with this centralization and automation is, as I alluded to in the title, is we're going to use some APIs. We're going to do some automation. And the cool thing is that this doesn't have to rely on fancy security tools that you're going to see down the show floor. And so you don't need to buy a special tool. You probably already own that tool. It might be something like an open source product like Chef or Puppet. It might be a commercial tool from Microsoft or someone else. But the idea is you can get a whole lot of leverage just by using those tools you already have in-house. So in the case of something like Chef or Puppet, all you need to, at that point, is you might have, today, if you're doing sort of operations the old school way, you might have 50, 70, hundreds of virtual machine images in your enterprise. You'll have one for every single version of Windows and every different version of Linux you deploy. It'll be like, I have one that is for my web server, and I have another one that's for my database server, and I have another one that's for the 14 different app servers I have. Well, that's bullshit. I mean, it may as well be cyber for all you know. So, thank you. The reality is that what you really need to do, what you really want is to minimize the amount of patching you're doing for your base operating system as much as possible. You're trying to manage multiple images, especially when you get into the dozens or hundreds of images, it just isn't tenable. You're going to screw something up, you're going to miss something. So instead what you want to do is leverage those tools like Chef and Puppet. Your ops people already have them in-house. They're already using them to do some patch management. They're already doing it to do some systems management. But really take it to the next step. This is third generation package management. So have one copy for each operating system, and that's it. And then have an architecture that says, hey, look at that. This machine needs a web server, and you click the button, and the latest version of the web server goes down, and what your configuration management is there, and that's huge. You can spend your entire time in the ops world doing, this stuff, compliance, change control, and you're stuck. You don't actually get to do the fun part of security, which is playing with some of the toys and things like that. But this is the stuff that bites you in the ass every single day. And your auditors are going to come in, they're going to say, tell me how many instances of Windows you have, and you're like, fuck if I know. Or your CEO reads in the latest trade rag, hey, there's a new, what about Flame? What about Stuxnet? What about whatever the latest crap is that I've read about, on CNN? And you say, how exposed are we? I don't know. I don't have a database of this shit. I don't know what I have deployed. Well, if you're using something like Chef and Puppet, you know exactly what you have deployed because you have a central catalog that automatically updates itself every single time you change something. Then you get to make your auditors happy because you can say, oh, I pushed out an update. And they say, well, who did it? Well, someone had to log in and do it, right? It's not just some random person pushing out patches as sysadmin or as administrator. So that's pretty cool. So, but there's other tools out there you can be using, and I have some more stuff later on this, which is there's Jenkins. So on the development side, there's this great tool out there. It's open source. It's called Jenkins. It used to be called Hudson. And every time you check in your code, it runs all sorts. It'll compile your code for you. It'll run your unit tests. Well, if you're running Java, there's packages like find bugs that have some security tests in there. So why not just automatically test your security every single time you do a code push? That's pretty cool. Wouldn't that be awesome? Wouldn't it be great to just be able to know that every time you deploy some code, it's being checked for all those vulnerabilities that you're constantly either yelling at your developers about, or if you're a developer, being yelled at about? Wouldn't you like to focus on the fun stuff? I know I would. So you may have heard, and I'm talking way too fast, so I better slow down for Chris's sake, about this whole continuous integration, continuous deployment thing. Who here has read about continuous deployment? It sounds crazy, doesn't it? You deploy more often and you get more secure. But it's true. I mean, that's the crazy thing is that one of the things that there was a study done that showed that every time you add X% of functionality to your code, the code gets exponentially more complex. So you add a little bit of functionality and your code will double, will get twice as complex or even worse in terms of complexity. And every time you add complexity, you have problems you're trying to detect. Is your code, where have you made bugs? Where have you introduced bugs? Where have you made business logic concerns? But if you do, it turns out if you do smaller changes, then you're actually introducing less complexity. So even if you want to deploy 5 features, say, you're better off doing 5 features sequentially, and you actually end up with a significantly smaller amount of complexity added to your code. Less complex code is more auditable, it's easier to find bugs in, it's all good. It also means your engineers can focus on hard problems rather than the easy one, rather than looking for stupid shit that should be automatable. Computers are really good at finding the basic bugs, so let computers do the let computers do the grunt work, and then you get to focus on the interesting problems and the hard problems, and then everyone wins. The other cool thing about this is that when you're doing small changes, when something goes wrong, it's much easier to say where the problem was introduced. Let's see, the problem wasn't here in version A. Version B, which was 25 lines of code that was added, suddenly something went sideways. I wonder where the bug was. Not only that, if this is linked to your build system, you not only say, this is the code that introduced the problem, you know which developer caused the problem, and you know who deployed the code. If it was an ops person who then approved the code, gives you the ability to start troubleshooting and doing some analysis to figure out what went on, which means your downtime is less, and that's all good. The Etsy folks, they're here. I don't know if they're in the room, but they're here at Black Hat. You should talk to them. They've done some excellent work around this. Facebook has done a bunch around this as well. There's a lot of good posts, a lot of stuff around that in the DevOps world. So I would definitely recommend checking some of that out as well. Of course, it's not all fun and games. This is where the fun stuff comes in. If you're designing an API, you want to make sure that you do it right, because suddenly, if you're giving people a lot of centralized control, if you screw up, wow, you've just given someone the ability to destroy, not just shoot themselves in the foot, but they pull out the really big gun and shoot both their feet off at the same time, and then turn around and hit everyone else in the room as well. So George Reese wrote a great book on API design. Read it, love it. It's like $5. It's on the Kindle. Yeah, so that's a pretty good deal right there. And speaking of APIs, you're going to hear a lot of talk about RESTful APIs and SOAP APIs, and there's a lot of religion out there. SOAP is the way to do it. REST is the way to do it. Pragmatically, at this point, the vendors everyone's embraced REST. It's a lot easier. It's a lot more. It's not as complex, which makes it easier for developers to use. It has a nice standard interface. SOAP does as well, but realistically, what's happened is that SOAP has become the Betamax in the open API world. In any sort of academic argument, you can list all the reasons why SOAP is a better protocol to use. It has message signing, it has all this extra complexity and granularity, but it's hard to use. It adds a lot of complexity to your code. It requires your developers to do a lot more work. and it just makes it's harder for people to understand. Versus REST, it's basically it's an HTTP interface, and it all works. All you need, documentation. You generally need like a paragraph to describe how to authenticate to that particular API, and then you just have a list of what happens in a get or a post, and magically, you can write some code to make it happen. Or if you're not me, you can write code to make it happen in a real language. And so REST is where it's at. Whether you like it or not is a different story. There's a lot of arguing and debating out there. In fact, some of my colleagues and I regularly argue the relative merits of both. But I mean, realistically speaking, it's REST. So you suck it up. Kind of like dealing with any number of vendors. They're there. You got to do it. REST is open, so write your own interfaces. So I spent some time, probably not enough, but I spent some time talking about using those ops tools out there. They're really cool. They really let you do a lot of things. Chef and Puppet are very flexible. They're dynamic. It lets you you can very easily add features and functionality, and so that's all real good. But sometimes there's security tools you just can't avoid. But a lot of them are actually automatable as well. The things I'm not AV, not that crap. But so one of the things that people would like to do and tend to do when they bring up a new compute instance, if they're doing cloud stuff or if they're doing virtualization houses, is this instance, did I get this configured correctly? Whether manually using Chef and Puppet. So ideally, you spin that instance up, and it would automatically get scanned. Whether it's using Qualys or Foundstone, whatever. And so, or Nessus, or it doesn't matter. You want to scan it. You want to know, did I cover all those basic, vulnerabilities those are covering? Did my configuration management, did I do the right thing? Because we're human, we screw up. And so I started to, I thought, I'm going to go out. I'm going to write a Java module. I'll open source it so people can just have a Java library to talk to Qualys because they have a reasonable API. And I'll open source it and I'll share it. And then as I was coding along and I relearned the fact that I haven't touched Java in like 14 years, and it turns out that I was a little rusty, and so the Java code didn't happen. And I thought, well, I started looking at it, and I said, you know what? This whole API thing is so simple, especially with a RESTful API. You can do this entire thing. I can hack this thing together with a friggin' bash script. And if I can put together a bash script to automate this stuff, there's really not an excuse for someone with real coding skills to put together something and use this. Either feel free to use this in-house. Feel free to do what you want to do. It's going to work. It's that simple. You fire up an instance on Amazon. It figures out what the IP address is. It adds it to Qualys. Qualys scans it. Boom. You get a report back. And in fact, let's go over here. I decided it would be fun, so I actually recorded. Where did it go? Let's see. Oop. The screen resolution is off. Let's see if we can fix that. Let's see if we can get this to work. This is why I don't generally do live demos. Let's give it a shot. Okay, hopefully that'll show up good enough. Look, we get XML back. And this will just keep running along. And the great thing about this is that you run your scan. Boom, you get an IP address back, it's added, the scan runs, you get a list of vulnerabilities back in XML, which you could then pipe into whatever other reporting engine you wanted. You could have this send off automatically to something like Splunk or Elasticsearch, so you have those reports are searchable. You could send that off to via another API. I could just shove that off to something that'll alert me as it finds certain levels of vulnerabilities. There's XSLT translation, so you can convert this to a more usable format than XML. It's just there, it just works. And like I said, this took me, I think after hammering my head against the wall of Java for far too long, I ended up coding this thing in like 20 minutes of shell scripting. It's that simple. The documentation's public. And it's, pretty much all the commercial products that do this sort of thing have similar APIs that are open and easy, and at least, if not that easy, pretty close as easy to make work. And there we go. We got a quick little report. And in this case, I actually I put together a very small scan so it would run quickly. This can take 10, 15 minutes, and I think you probably didn't want to watch XML streaming by on screen for 10 minutes while it did its thing. But it's really that quite straightforward, and it's a great way to identify how you're doing, and also just quickly identify those vulnerabilities. One of the things that we also learned from the Verizon reports over the years with these vulnerabilities is that the essential thing is not how fast you patch these things, but how thoroughly you patch them. So when you want to identify new vulnerabilities earlier rather than later, one of the advantages of using these tools like Chef and Puppet, like I talked about, is that you get really great coverage. So if you have a vulnerability out there, whether it's SQL injection or if you have a relatively wide open network like a university, then what happens is it doesn't really matter if you have 99% of your machines patched, if you have a few machines that aren't, that you don't know about, or that you missed because they were, you just missed for whatever reason because someone was going down a list and manually operating these things. And so this sort of automated scanning lets you identify those machines right away, and that's super helpful. And so then what I did was I said, you know what, well, we should be able to write do something similar on the code commit side. Talk a little bit about that, and where I said, what we got here is the ability that as you commit your code, it should it compiles and tests, and well, like I said, there's things like find bugs, and I've worked with companies in the past who developed quite a number of integration unit tests to look for those obvious security vulnerabilities that you shouldn't be doing, so you can focus on the hard problems. And then I was talking with Jeremiah and some of the folks at White Hat the other day, and they have an API, it turns out, because all the cool kids do. And I thought, well, how would I make, how would I integrate something like this to my code system? So I said, I spent some time talking to them, and I don't have an account with White Hat, so I couldn't actually put up something more complex as the code. But it turns out, if you want to test, you run their product and you get a list of vulnerabilities. Well, you want to know if you fix them or not. Well, it's as simple as once you've logged in, it's a simple put request. You can just you say, here, retest these vulnerability IDs. Just do it, and it'll just run those particular tests, and you get a report back right away. And if you fixed it, and if you fixed it, if it passes the test, great. You can push it onto the next step of your production testing, whether it's actually production or the next step of testing. Or if you failed, well, don't even bother moving forward. That bug is still there. You've decided that's important enough. It's one API call. So one of the things is that this space is pretty nascent still. Folks like Chris Hoff have been talking about it for a little while. Lisa Lorenzen, also at Juniper, has been talking about it. We've talked about automation. We talked about APIs. In some sense, for ages. Anyone remembers 1998 when Network Associates announced active security? Anyone aside from me actually remember that? Oh, thank God. It was this idea that you could, when your network sniffer detected what looked like an attack, it would notify your firewall, and it would automatically turn off ports. And then it would open up a ticket with the help desk. And it was like, ooh, that sounds kind of like a really good idea, at the same time a really terrible idea. I can think of all sorts of interesting ways you could DDoS things, especially if it wasn't very good at detecting forged packets. And it failed miserably because it was completely proprietary. The APIs were impossible to use. You had to license everything. It only worked within their tool set. Checkpoints made similar mistakes in the past. And one thing that's really held back this idea of leveraging automation really well is the fact that until recently, APIs weren't very open. There wasn't standards for doing this thing, and the tools weren't really there. So there's a lot of room here where we really need to move forward and make a lot of progress in general. So this is a great spot to really leverage things and move forward. The cool thing is that Juniper has APIs on all their stuff that you control all their gear via APIs. They actually have two different APIs you can use. one of which is even a public RFC since, I think, 2004. So that's pretty forward-thinking in the general scheme of things. They have a new one, which is pretty cool because it's kind of like cloud stuff abstracts the hardware away from you. Juniper's done the same thing with their hardware on the network side. So you don't need to know the specific hardware you have. Now you just say, oh, it's a switch, it's a router, it's a firewall-like device. And that way you don't need to worry about the intimate details. The back-end code deals with that problem. Actually, Netflix did something similar to that to make life easier for them with their hundreds of devices they support. Not from a security perspective, but it's the same idea of abstract as much as you can. It makes life easier for the developers and for the users. F5 has every function you can do on an F5 device, whether it's a security function or an operational function, is controllable via their APIs as well. So long term, my plan is to actually dust off those Java skills or recreate them as the case may be, and then actually start releasing control libraries for these devices so that way security folks can, security and operations folks can really leverage those tools to make life better. As soon as I get things, more together, I'll actually start putting things up on GitHub or someplace like that so people can contribute. The idea is just open source, play with it, use it, hopefully make it better than anything all code. And so, like I said, there's a lot of work to be done here. It's really nice. I just saw on Friday that someone actually just published a book on automation and security. I have no idea. I didn't recognize any of the names, so I have no idea who it is or if they're here or not. But it's probably worth at least taking a quick peek to see if it's any good. Was there a question, or you just no? So please, this is definitely, like I said, this is. I don't want to say it's cutting edge because it's not. It's not. Crazy hacker, stuff like some of the things you'll see later this week. But it is, it's where we need to go as operational security folks just to get shit done. We have less. We increasingly have fewer resources to do this stuff. We're not going to be getting more money anytime soon. We certainly don't need silver bullet pieces of application stuff that you're going to find on the show floor. They have good toys. I got a great boomerang or something from some vendor. I have no idea who they were or anything, but it was a nice toy. So that's the kids will be happy. But so really, focus on the tools you have. Take advantage of the opportunity to really actually show that you can make a demonstrable improvement to things using these tools. Make life easier for other folks, and then you'll have time to do the fun stuff, and you can sort of you can actually get ahead of the curve on some of this stuff and focus on the harder problems. And I've talked way too fast, but that's my story. So hopefully people have a lot of questions. Yes. The book is API REST Design, I think. It's by George Reese. It's a Kindle book, and I think it's going to be on iBooks as well.
Is this thing on? Hello? Yeah, I have a few questions. I don't know if this thing works, but I'm trying to figure out, you talked about automation and REST APIs, but I didn't really get any of that in this presentation. I'm trying to understand what are you talking about in terms of testing a REST API in an automated way, because REST API is unlike WSDL, unlike SOAP services, for example. SOAP services give you a WSDL. You can get the WSDL and get all the APIs you're looking for.
Right.
How do you automate testing a REST API that doesn't have the interfaces defined for you? I was trying to understand, how are you automating that?
Well, okay, so it wasn't so much about testing the API itself, though that may be necessary if you're developing an API. It was more about leveraging those APIs to test your code. So like using calling tools like Qualys or White Hat or find bugs internally. Okay.
So really what you're talking about is building a mashup out of your information security world, right?
Yes, exactly. That's a great way of putting it.
So if you're talking about building a mashup of your information security world with REST APIs, how do you deal with the problem of information occlusion and having to occlude information for different levels of access?
So, okay, just to make sure I understood the question correctly, what you're asking is, as you're gathering this information from your testing, one of the things, how are you, quantifying that data, and how are you restricting access to different individuals who might need access to that data?
Right.
Yeah, that's a great question. It's sort of a general information problem of, how do you classify information and how do you deal with that? Some of that you can manage via access control lists. Some of that's going to be you want to leverage tools like Splunk or Elasticsearch that can actually let you tag data as it's coming in. So you can say, as data comes in here, it's tagged as web app scan data versus versus infrastructure scan data versus code scan data, and then you can leveraging those tags, you can then say, here's what people can search on and here's what they can see. Elasticsearch is a open source log management product. It's excellent. It lets you do that kind of thing. Obviously, Splunk does that as well.
That makes sense. Do you have any suggestion for visualization APIs on the mashup?
That's kind of outside my field of expertise. So.
Okay, cool. Thanks.
And I do know a lot of people like graphite. So
I have a question in terms of managing things with Puppet. Do you find yourself writing a lot of the Puppet scripts yourself for specific services? Let's just say like Apache. Are you writing your own Apache module, or are you downloading one that others have provided online?
I've almost exclusively been able to leverage existing community packages or ones from Puppet Labs or from Ops Code on the Chef side of things. And then really what happens, where all the manual stuff is around the actual manifest for the actual configuration files. So in terms of like specific configurations for particular sites.
What was the name of that second repository you kind of mentioned?
Oh, it's OpSource. It's from they make Chef.
Okay, and then what about with Puppet? Some of the things that we noticed that we run into problems with is wanting to manage a service, and you perhaps have like a password that you need to deploy out somewhere.
Right.
But you don't want to necessarily have this plain text password floating around in your manifest and being shotgunned all over all these computer systems there. Do you have any strategies for protecting passwords that need to be deployed with?
So credential management is a huge problem in the operations world. Obviously, because of that very issue, you don't want to have passwords just sitting in clear text. There are a variety of there's a bunch of commercial solutions that you can integrate in with things like Chef and Puppet to handle that. I'm happy to talk with you about that offline because it's more product specific.
Okay.
Thank you. Yes? Okay, that's the question was, what was the name of the book? That's George Reese's API RESTful API design, I think is what it's called. It's on the Kindle. If you just go to the Kindle store and just search on George Reese, it'll show right up. Okay, thank you.